Biological Sciences 220. Biological Sciences 220. Biological Sciences 220, Spring 2011, lecture for March 9th by Albert Herrera.
So this was the last slide. So this was the last slide we talked. Let's say blood vessels. Let's say blood vessels. Let's say blood vessels. As well as a big sensory component, because in order to, it's not just commands going out to organs, it's also a sensory component because the brain needs information about what's going on in order to generate the proper commands. Anyway, that's the autonomic nervous system. We'll talk more about it later, but it has two major subdivisions, the sympathetic subdivision and the parasympathetic subdivision, and most organs, not all, but most organs receive nerves, they receive innervation from both subdivisions, and the heart's a good example of that. In many cases, but not quite all, when an organ receives innervation, nerves from these two subdivisions, the effects of the two subdivisions are antagonistic. So in this case, sympathetic nerve activity results in an increase in heart rate, which is also called tachycardia. That's sympathetic nerve activity. And that is mediated by the release of the neurotransmitter from the ends of the nerves, neurotransmitter norepinephrine. The norepinephrine binding to receptors on the heart causes an increase in heart rate, also known as tachycardia. It's called tachycardia. And parasympathetic nerve activity, releasing the transmitter acetylcholine, causes a slowing of the heart rate, also known as bradycardia. So tachycardia, bradycardia are opposite effects, opposite phenomena, speeding up and slowing down of the heart, respectively. And so putting together this information with what we talked about in the previous slide,
you might